Hello, I'm Chris Jenkins. I'm the CEO for Thales Australia, a global leader in mission-critical systems for defence and aerospace. In 2010, the F-111C aircraft will be retired after 40 years of active service with the Royal Australian Air Force. Redeye is the story of a group of innovative Australian engineers that helped propel the Royal Australian Air Force to the very forefront of mission training and simulation. It's also the story of how strong customer focus and collaborative work between defence and defence industry has brought exceptional results for the Royal Australian Air Force. We're very proud of their achievements, and I hope you enjoy their story.
We'd been building the control systems for the Collins-class submarine, so the big question was, what next?
Our knowledge of Wormald was that they were people who built firefighting equipment facilities. We weren't really too sure about what they did as far as flight simulation went.
The intensity of the flying is phenomenal.
It was a challenge, and we were looking for that.
Flight simulators generally teach you the basics about flying the aeroplane, but a tactical mission simulator teaches you to operate that aircraft in a complex combat environment.
At Wormald, we'd done a lot of work actually in buildings and offshore oil rigs. We found that our expertise was directly applicable to the submarine, and so the extension of that to an aircraft is a lot closer than you might think. The expression of interest from the Commonwealth was finishing at 4 or 5 o'clock in the afternoon, and I had about 20 minutes free, and basically I whipped off a one-line fax.
So we got this fax from Wormald, which one-line fax which said, "We're interested in bidding for the F-111 simulator." Now at the time we thought, interesting. My initial reaction was, well, I guess the simulator won't burn down.
Well, Gulf War 1 was a key element of showing us how mission simulation, mission rehearsal could really improve the capability of crews flying the operation.
There were a lot of things that you couldn't do in the aeroplane that you could actually do in the simulator. A lot of the threats, the surface-to-air missiles in a normal training mission in the aeroplane, you couldn't replicate them.
The F-111 is unique because it can go faster and lower and carry more weapons than almost any other platform.
It was originally designed back in the 60s, to fly below enemy air defences, and its chief advantage was that it could come in at quite low level and at very high speed. Of the 8 aeroplanes we've lost, over half of them have been lost at night at low level.
Without this modern simulator, we risk losing crews in accidents, and we risk not having the credibility and our deterrent effect desired for the F-111.
On paper, it looked like the risk was very, very high because we'd never done a simulation system before. But if you really understood what the risks were, like Jeff did, then you knew that in fact we had the skills and the capabilities and the teaming partners to do the job.
A problem arose with one of their partners, which no longer made them a viable participant in the program. Wormald were very dejected at that point because they felt that they may have lost the opportunity altogether.
We were definitely caught in a difficult situation.
The circumstance of that relationship failure led 2 of their key personnel to come and join Wormald and help them deliver the simulator.
Well, when Mike and Joanne came on board the project, we were confident that we would succeed because we'd been dealing with them from the start of the tendering process, and it was really them that we relied on.
Mike had quite a bit of experience building mission rehearsal simulators for special operations forces in the US before he came out to Australia, and prior to that he worked for NASA on the Space Shuttle program.
6, 5, 3. the F-111 is a lot more complicated than the space shuttle, believe it or not.
So when we got the message that we were the preferred tenderer, Jeff Northam rang. I think I nearly fell off my chair, and the next thing that we decided to do was go to the pub, the DY pub, to drink quite a lot of beers to work out what the next step would be.
There was a monumental task there to sort out what we had to do, get some viable schedules together, get a team together and start them working, and try and figure how we were going to somehow meet the schedule, because we had a 3-year period to build this thing.
The hardest part between 1993 and 1997 was getting this team of multicultural people from all over the world together to build a simulator that no one had ever seen before.
He became Aussie Mike because he got naturalised, but there was another guy who was around, another Mike, who was brought on board while we were testing the thing, and he was an American Mike. So we had Yankee Mike and Aussie Mike, and we had old mate Sov. It's like working in the United Nations.
You know, here's an American and here's an ex-communist working together on a classified Australian project. We would go to a meeting in DSTO to talk about one of the weapons. This whole team at DSTO break out in Polish, and then they decide, oh, Mike doesn't have a security clearance. We need to talk about this Texas Instrument weapon, so Mike has to leave the room.
Yes, I know that Mike Rainey works for NASA, but I didn't know that he was taught by Neil Armstrong. Oh, that's I didn't know that.
During my education, I went to the University of Cincinnati, got a degree in aerospace engineering. My instructor was actually Neil Armstrong. Literally speaking, there was only 3 of us in the class. This was after he came back from the moon.
The company was going through a typical project cycle in a company. We'd come off a big project and we were on the downhill slope, particularly with personnel and numbers dropping and the amount of work we had. And F-111 just turned that right around. So we're all quite excited about it, quite keen to get onto it.
Well, right from the start, we knew we were up against it because we'd outbid the big boys and they'd never done a simulator before in Australia. So these guys are really keen to prove that Australia could do it.
In terms of the timeline, the team was always under pressure, and it was one of those things that as we went on and discovered some of these unknowns, the pressures mounted all the time. The aircraft itself was being upgraded and the simulator had to be ready to train pilots for the new aircraft.
Fundamentally, the original contract was to build an F-111 simulator based on an existing F-111F simulator. So we were provided a cockpit, admittedly not an F-111C cockpit, an F-111F cockpit, and we were provided a whole bunch of electronics and racks and cables.
There was many parts missing from an F-111F simulator. There's multiples of some things and none of many other things, boxes and boxes of cables, and very little documentation as to how to put it all together. So almost immediately that was just not going to happen.
So we never had to upgrade the old simulator. I think that there was an implication with many of the contractors that would be the cheapest path forward. But what it meant was that the simulator would never be able to be upgraded over 10 years because the equipment was so old.
Well, effectively we decided to build a new simulator from first principles because A, it would reduce risk, but B, it would be more attractive to the Air Force.
What we did have to do with the cockpit was cut a lot of metalwork off it. It was originally designed on a motion platform, and our requirement was to remove the motion platform, so we chopped all that off and put a stable base underneath it.
We had a mock-up of the Amberley facility. We'd mocked up, using gyprock and timber and builders and stuff, a replica. So we got all our cable lengths right and we got the equipment in the right position, and everything was duplicated as much as we could. Cheaply, but done. And we had our own, in a warehouse, we had our own little building inside a warehouse.
I walked in the warehouse and my first reaction was disbelief. Packing crates everywhere. It looked like an aeroplane had just been exploded, so instrumentation, wiring looms. You walk in a little bit further and there's the main room where the engineers are working. Chocolate wrappers, Coke cans, big eyes, ponytails, wall-to-wall computer screens with guys just doing that.
To get the visual system to work, of course, the first thing you've got is the projector. That projects down onto the screen, which is a curved screen that's 150 degrees by 50 degrees, centred on the pilot's head, so it's a spherical image that's projected down. The projectors themselves are made to project onto a flat screen, so they need hardware added to them to make them project onto a curved screen. And feeding that, of course, is the image generator itself, which is an SGI computer. In our case, we've got 3 projectors, so they have 3 computers, 1 per projector.
The image generator is unique because it has to support both high altitude mission operations, which they can sit up at 50,000 feet and drop weaponry, and at the same time, this aircraft can fly 200 feet using a terrain following radar.
We took a SGI 3000 series, which is a supercomputer, but we did it in stages. So we started out with 64 processors, and over time we added more and more modules, so increased its size and capability.
There was a complete shift in technology that was happening in the industry, and we rode that technology shift. And that was a shift from the old flight image generator companies to new companies like Silicon Graphics.
When we got to system integration, we had all the equipment in there. The guys were getting the software onto the computers, getting the computers talking with all the hardware, making sure it all worked. That's when the guys started pulling night shifts.
There were project guys, RAAF project guys actually living in DY. So guys like Jeff Northam, BJ Walsh actually on site who were able to keep that customer focus working from day one.
This platform is not like your normal platform. It's got swept wings, it's got slats and flaps, and the swept wing concept actually really does change the center of gravity and the moments of inertia, etc.
Well, with an aero model, the aero model has to replicate the type of aircraft. The F-111C is very different to an F-111F. The F-111F has shorter wings and a kind of a different centre of gravity and a few other bits and pieces of peculiarity. So Wormald had to take the F-111F aero code and basically turn it into an F-111C using DSDO data.
Neil Armstrong was actually a test pilot, a NASA test pilot, and he would take these aircraft up into space and he'd fly around and he'd perform and they'd collect all these data points. And at the end, that's what the simulator is all about, is actually reproducing in the simulator all those data points.
You can control the system, let's say autopilot, and you can gather all the information about the real autopilot components. You can model every single component, as faithfully as possible, and you use correct equations from the control system perspective. Or you can use another approach, which is used sometimes, a fuzzy logic that only deals with approximations, and sometimes the results are comparable, sometimes even better by using approximated models, because you cannot faithfully represent the reality because it's very complicated.
When you're delivering a flight simulator, you can only do the instrumentation and the measurement. You can only take it so far. At some point, subjective measures come in from pilots. It doesn't feel right, it doesn't behave in a certain way, and people would call them the golden eye, or the golden hand is another term that's used to describe it, because they can tell from the flight controls it's just not handling quite right because they have the knowledge. If for some reason Steve got labelled the golden bum.
I'm the guy who's never worked a day in my life because I'm doing something I absolutely love.
BG and I became best friends because I think we both shared the enthusiasm to make this project a success.
We soon found that with a beach about 5 minutes away from the facility, you could be down and back within an hour and get about a 30-minute surfing session in.
They'd probably been working 16 hours before they went surfing at lunchtime, and then they'd be back working till midnight.
In mid-96, they decided that the thing was going to be ready in January 97, so they terminated the old simulator. And once they'd made that decision to turn the old one off and had started cutting the power cables, and that was it. We had to get the thing up here by January 97 or the aircraft was in dire straits for training.
We were running dangerously late with the project. The digital radar landmass system wasn't working, and without it you can't run the terrain following radar or the attack radar system. Well, one of the things we had to do to recover schedule was to make the simulator available in DY for an Amberley-based conversion course.
The avionics update program required a total rewrite of the conversion course syllabus, so the old simulator can now no longer be used. So we've got to get some sim training in. So we'll have to push all of the sim training into a fairly tight 1 or 2 week period and take the guys down to Sydney. Great for the Air Force guys, but what that means is the poor buggers in DY have now lost access to the device through 1 or 2 weeks day shift. So back to the night shift, boys. So if they came down to do a training sortie that maybe needed the radar, we'd have to kind of limit the areas of the radar that they used and still meet all of their training requirements, because at the end of the day, it's about meeting the training that you need for the aircrew who are out there flying the airplanes. But our job was to kind of just smooth things around, give them the training they needed, keep some stuff out of sight until it was fixed the next day, and then fold that back in there.
The RAAF they'd done in-plan accepting in DY, but they were still not going to accept it necessarily when it went live in January in '97. And they said to us, if the test pilots go in there and they don't accept it, we're not going to accept it. You'll have to keep working on it. And then there's going to be repercussions because the fleet will be grounded.
Getting rejected in 1997 was not unexpected. We recognized at that time the simulator wasn't ready.
Well, I had no choice. It wasn't meeting our specs. I couldn't accept something that was going to put F-111 crews' lives in danger. It's as simple as that.
I should imagine from a management perspective, it was quite a significant blow.
Very disappointing for the staff. There was quite a bit of a morale issue, as I understand. But certainly, as we went through the process of re-engineering the project, people understood the significance of getting it right.
Thales took over Wormald technology when the second phase of the F-111 simulator was still in progress. One of our customers, when we were delivering some simulators once, said that Thales delivers the Rolls-Royce of simulators.
Well, in the end, we decided that we would actually ship the simulator to Amberley, and it would be used for doing part of the task, so part of the mission simulation. But some of the details, such as the radar, would come later. So the Air Force could use the simulator for doing flying training, but not really complete mission training.
So to develop, we had to work around the hours in which the aircrew were actually training, which meant we had to work at night.
Engineering staff through the night will work to put fixes in place to meet the needs of the conversion course the next day. Very challenging, but they were getting live feedback on how good or not the simulator was.
And being on a RAAF base, they were also, during the day, they were running the engines, so there was a lot of noise. Originally we were staying in the officers' quarters on the base, and it wasn't sustainable. The guys were getting no sleep during the day and then working all night.
I led a rebellion against the management at Wormald Technology at the time, so we have to stay in a hotel.
And fair enough too. I mean, these guys are only taking 4 or 5 hours a day off. You can't afford to spend that time lying there in a 30-degree room, with TF-30s running outside your window.
The team shrunk to a software support team because the majority of problems in the simulator were actually software.
Probably the two biggest obstacles before final acceptance were both significant in training, and they were the terrain following radar functionality, which was not up to speed, and the PAVE TAC, which is a laser targeting device on the aeroplane used for weapons delivery.
There's two parts to the radar on the F-111. There's a land mapping radar, which gives you a picture out into the distance of what landforms there are ahead. And it also has an aerial mode where you can search for other aircraft. The other half of the radar picture is the terrain following radar. And that's where this aircraft can get down low and hug the terrain at high speed. And this thing is extremely critical because they're putting their life in its hands. So the two data types we got from the Commonwealth were elevation data, which was spot heights, elevation data of the terrain area showing height above sea level, a huge matrix of that information, and from that you can put together the shape of the ground, mountains and valleys and things like that, coastline. The other type of data was feature analysis data, and we were able to then take those two forms, merge them together and produce the visual database from that. We also came up with some tools to generate the radar database from the same source information, which then allowed us to have excellent correlation between the radar and the visuals, which was an important training cue that they required.
PaveTac is a very important part of the F-111 capability. It's an imaging system that allows you to detect targets in all sorts of night conditions and day, and then use a laser to target those for precision-guided munitions.
PaveTac is a supplement to the attack radar system. The attack radar system is essentially the big picture. PaveTac is the small picture. So when we find the target area, we want to use the radar to be able to get the PaveTac to have the target within the field of view.
There were a number of obstacles that we had to get through with PaveTac. One was the actual modeling of the PaveTac system itself, and two was the infrared imagery that is actually projected in the cockpit.
Because the PaveTac works on temperatures rather than on colours, we had to come up with a way of modelling the temperatures into the database so that we could have one database that we could use for the out-the-window scene, but also use for the PaveTac.
Watching the sunrise, we'd be delirious by the end of working a 12-hour shift through the middle of the night, night after night.
We had a problem, you'd throw it at Andrew and you'd pretty much guarantee he wouldn't go home until the problem was fixed. So 30, 40-hour shifts, whatever it took.
It doesn't matter how many hours you sit, but whether or not you at the end is there any positive effect of that. And in this case, I was lucky to say that I had achieved what I wanted. It was kind of impossible mission.
The actual cockpit room where the crew train is very cold. It's only like 16 or 18 degrees, or it was back then, so it was a very, very cold room. So we were very nervously awaiting the crew to finish their training and to come into the instructor area and give us a verdict on whether the simulator was good enough for the crew to train and then move on. And the test pilot came out, and even though the room was very cold, he had sweat rings under his arms and sweat rings down his back. So the emergency training he'd been doing, he'd been fully immersed in it, and he was obviously really into the simulator. And that was as good as 2 thumbs up to us. We knew before he said a word, the simulator had been accepted.
You're upside down at that stage. You're on your way. Cool. All right. As long as you're about to be in the game, you're on. At the moment, they're part of a coalition package, so there's 4 strike aircraft with support, about 6, we call them blue air support. So they've got their own fighters accompanying them, and they've got guys in there with the specific job of suppressing enemy air defences. On the other side, there's about 6 red air waiting for them, so there's a squadron of MiGs. They've got a couple of laser-guided bombs. They've got to take down a power station and then get themselves out of Dodge and back home safely. At the moment, in the short term, the red air's been tied up by blue air, so they don't have to worry too much about fighters, but they've got a couple of fairly intense bands of surface-to-air activity. So at the moment, their main focus is in surviving and avoiding any of the AAA. What you're seeing right now is the guys, in fact, avoiding a bunch of surface-to-air activity. The aircraft's got quite a few self-defence options, so it's got chaff and flare. It's got electronic self-defence as well, so they're using a combination of those, plus using the terrain. The best thing we can do is hide behind hills or in valleys. And the guys are manoeuvring the aeroplane in 3 dimensions and using all of the electronic countermeasures to avoid these rather nasty little surprises we've got for them. At the moment, they're working below 250 feet. They're authorised down to 135 feet in today's scenario. And they're travelling at around between 550 and 600 knots. They're pretty busy at the moment. On top of that, they're managing aircraft systems, bringing up weapon systems, making sure the bombs are appropriately armed. The guy in the right seat's now got to manage his sensor suite to make sure that the bombs are aimed at the right point in space. So it's typical of a lot of simulated combat sorties, it's 80% boredom and 20% sheer terror. At the moment, they're going through sheer terror. With sim training, you try and balance training outcomes versus their repetition of their competencies. So we can't beat them to death every time they come in here, or they won't want to come in here. So at the moment, their focus is on using the aircraft successfully to deliver this weapon. When they come off target, then we'll stress them up a bit, and we'll try and take them to the next level of training. So the ability to multitask is very, very important to these crews. So as well as flying, managing their own systems, they've got to be able to talk to the rest of the guys in their package, keep SA of where the fight is, so they know, well, when I come off target, there's going to be a fight 30 miles to the south, I can't afford to go there. They're getting towards the business end of it now, so they're about a minute away from a weapons release. They've got one more belt of surface-to-air missiles to fight their way through, and then we'll let them get their bomb off. So right now the right seater's starting to focus in on his systems. He's using his radar and his PaveTac infrared pod to find the target and get the laser designator pointing at the right spot. The left seater's focus now is on picking up all of the tactical work involved and flying a toss delivery, which in itself is a very demanding three-dimensional manoeuvre.
The toss manoeuvre is designed to throw a bomb a fair distance, and that's the purpose of it. So the aircraft comes in at a reasonable speed, somewhere between 540 and 600 knots. 4G pull up to release the weapon, roll, turn, guide the weapon in at the same time from the right seat as the pilot's flying the manoeuvre from the left, roll out, re-engage the autopilot on the TFR, back down and away.
Ray's just building the pressure now, so oh my god, these guys are getting closer, we're still guiding our bomb in. The laser's firing, the bomb's tracking it. Beautiful. So he's hit the point on the ground that he intended to. Now they've got to stay alive and get out of dodge. The guys and girls out flying the aeroplane now are doing things in the simulator that they could have only dreamed of 15 years ago. Fighting modern regional threats, using the aeroplane to the maximum of its capability.
After 2000, working now as part of Thales, we took the simulator from a good simulator to a great simulator. We introduced some high-fidelity simulations of the electronic warfare self-protection suite, the radar ordering receiver, the electronic countermeasures dispensing set, and as well as the AGM-142 Popeye cruise missile.
When the aircrews come back from their overseas exercise, the first question we asked was, how did it go? Did we have it right?
The advantage with the simulator was that we could actually recreate Nellis Air Force Base. So when the guys actually flew out of there for the first time, they had those procedures down pat.
We do literally everything from training somebody who has never seen the aeroplane before. Day one, we'll spend an hour teaching them how to turn the engine on, and that's all they'll do on their very first sim. 2.5 years later, those same crews are down here flying out of Nellis Air Force Base in the simulator, leading a 25 aeroplane mass strike against defended targets with surface-to-air missile systems and a whole bunch of MiGs and Sukhoi out there.
You can make mistakes in simulators and you actually survive. You can't make mistakes in a real aeroplane. So, but use of the simulator allows junior air crew to make those sort of mistakes and learn from them without any tragic consequences.
It was a man pad, so we should have got flares out. So a bit of a problem with that one. Through that belt very, very nice. Manage those puppies nicely. Target with the results, and egress, and that's your MiG, and you shot him.
Oh, so good one. Yeah.
Big thumbs up.
That was a good mission. We hit the target, so.
2006, an F-111 on takeoff actually lost a wheel. We were able to use the simulator to look at a number of approach options to get that aeroplane back for a wheels-up landing, approach and cable engagement. And once we'd used the sim to come up with the correct approach angle, or the most optimum approach angle, we passed those numbers to the crew airborne, and they executed it perfectly, and we ended up with a fantastic result of a safely recovered aeroplane.
Without the simulator and Steve Clark and Mike Rennie and the guys in the team, that story might have ended in a completely different manner. So you've got to have a certain sense of pride and achievement when something you've worked on is out there saving aircrew so they can go on and fly another day.
I think one of the keys to the success of the F-111 simulator project was having the Commonwealth and experienced aviators working hand in hand with Wormald's engineers in making sure that they could continue to improve the simulator to even better meet the requirements of 82 wing.
Yeah, the aircraft will be retired in 2010. I think if you look at it, we've owned the aeroplane for nearly and operated it for nearly 40 years. And it's been an incredible aeroplane over that period.
It was very disappointing to hear that they were finally going to retire the F-111, but had to happen eventually. I'm glad that we had a simulator that saw it through to the end of its life and that we produced that. Very proud of it.
It's been a very satisfying project and I think a very important project for the Australian simulation industry.
Very, very sad, but I've got no doubts that what's happening is absolutely in the best interests of the greater defence of Australia.
I'm seeing it from the acquisition phase all the way through the through-life support phase. So it's 17 years of my life. No regrets. It's a fantastic project, it's a fantastic team.
Well, I'm not sad. I mean, it's actually exciting because we're moving to the F-35. So the F-35 program, the Super Hornets are coming in. So there's all these capabilities that are moving in to take its place.
It was a beautiful thing. It certainly was a beautiful thing.
It's been a great investment for the Australian government.